it's going to separate into hydrogen ion and chloride ions. How do ions get across the plasma membrane? Through pumps or through channels, right? So when we look at these cells here, we put tight junctions in so that the HCl couldn't seep down in between two cells. And then we're going to make sure that these cells don't have any channels or any pumps for hydrogen or chloride, so that we can't pump hydrogen across the wall of this cell, or we can't pump chloride across the wall of that cell. So we're going to put a mucus barrier across all of this. We're going to make tight junctions so the hydrogen chloride and the enzymes can't seep between the cells. And we're going to make sure there are no pumps and channels so these things can't cross the cell and get deeper into the wall of the stomach. And we're going to do one last thing. We're going to allow those epithelial cells to replace themselves very often. So about every 5 days or so, all of those epithelial cells are replaced. So very high mitotic rate. So if the cells were to get damaged, and that would make them more susceptible to allowing these enzymes and acids to get through them, we'll just replace all the cells and then have a whole brand new layer of epithelial cells. Okay. Questions on that? Okay, a couple more things before we break. So, in the stomach, what the stomach does, it's going to be able to hold ingested food. So we're going to be able to put food in the stomach, and that food is going to start being mixed with these different gastric juices, these secretions, these enzymes, and we're going to break that food down physically, mechanical digestion, mostly through segmentation. We're going to churn the heck out of the stuff. Then we're going to allow hydrochloric acid to start denaturing proteins. We're going to allow pepsin to come in and start cleaving chemical bonds. And we're going to make sure that the particles in this chyme, so now all that juice and the food, all of that mixture is now called chyme. And we want to send that material over to the small intestine. Now, we can't send all of that material all at once to the small intestine, because that would be a huge amount of acidic fluid going to the small intestine all at once. And that would damage the small intestine, that would cause huge water shifts, huge osmotic changes, and water would start flowing all over the place. It would be very bad. So we have to deliver that chyme in little spurts over to the small intestine. And it's only going to be able to go into the small intestine as long as those food particles are small enough. If those food particles, I'll come back to these on Thursday. Let me just go over here. This pyloric valve right here is going to act like a filter. And as material is moving from the stomach over into the small intestines, this pyloric region here is going to undergo peristalsis, and with every wave of contraction in this pyloric region, you're going to get about 3 mils of chyme moving over into the small intestine. Now, if those particles of food that are in that chyme, if they're too big, they're not going to fit through that pyloric valve, and they're going to get kicked back this way. And if they get kicked back up here into the body, this is where we're going to do a lot of segmentation, and we're going to keep pummeling that material. As that material comes, as that chyme comes down into the pyloric region, peristalsis is going to happen here. And if those particles of food are small enough, then they will go through that pyloric valve, and that chyme then will come to the small intestine. So what that means is, even if we're at the point where we're moving chyme out of the stomach and into the small intestine, the stomach still has to store that food because it's going to take a while for that material to come over. So for that material to come over, for chyme to come over, it has to be small enough to fit through that pyloric valve. And we have to have space in the small intestine for it to come over. So if our previous meal hasn't moved out of the small intestine yet, this food that's in the stomach can't move into the small intestine. So it's like an assembly line. Things are not going to move forward until the previous meal has moved in a forward direction. So this is one reason if you have slow motility through the GI tract, if things aren't moving fast through the GI tract, you can have a lot of gastric problems and a lot of heartburn, because what will happen is that food will sit in the stomach longer than it should. It should stay in the stomach about 4 to 6 hours, and then it should be moving into the small intestine. But if your previous meals have not gone from the small intestine to the large, and from the large intestine to the anus and out of the body, so a couple previous meals haven't moved forward, that food's going to sit in the stomach, and as long as there's food in the stomach, you're going to have pepsinogen and HCl being released, pepsin being produced, this positive feedback loop being set up, and it's going to cause the stomach, these gastric juices, to become really acidic, too acidic. And that can start to damage that cardiac valve. That can start causing material to go up into the esophagus. It can induce vomiting. It can cause all kinds of problems. So slow motility is a big problem for many reasons. Big problem for the stomach. Now, so the stomach can hold ingested food. It's delivering chyme to the small intestine via that pyloric valve. The stomach is going to secrete intrinsic factor. Again, it's not going to be active until it hits the small intestine. And at the small intestine, it's going to allow for absorption of vitamin B12. In the stomach, your major nutrient absorption happens here. So we're not going to absorb any carbohydrates, any glucose. We're not going to absorb any amino acids, no fatty acids or glycerol, no ions, no vitamins. However, we can absorb some lipid-soluble compounds, like aspirin can get absorbed in the stomach. Alcohol can get absorbed here in the stomach, but no nutrients, nothing that our body is using to power our cells. That's not going to happen here. On Thursday, we're going to talk about how do these cells of the gastric glands, how do they know to release pepsinogen, HCl? How do they know to release gastrin? What does gastrin do as a hormone? So that's where we're going to pick up, and then we'll go into the small intestine.